Alright, so section 5.2 is on that last of the four main math operations. We did adding, subtracting, and multiplying. Now we'll talk about dividing. And there are two main goals. You want to learn how to divide using something called long division. And second thing is we want to learn how to use something called synthetic division. You'll get the same answer either way, but in certain cases it's better to use one versus the other. So we'll talk about each of those. This right here, this example is just basic division. The way that you would do this is the same as if you had something that's not quite as complicated. So if you had 8x plus 4, let's say, divided by 2, what you would do is split this and make each of these over 2. And then you would just do, sorry, it's supposed to be a 4, do that division. So 8x divided by 2 is 4x, and 4 divided by 2 is 2. That's the same thing we'll do for this. So we'll take each of these terms, 6x to the 4th, y to the 3rd, and we'll divide each of them by the denominator. So the next one is 12x cubed, y squared over 3xy. The next one is supposed to be a minus. Next one will be 18x squared y divided by 3xy. And then we go down the line and just divide each of these using the rules that we talked about from 5.1. So 6 divided by 3 is 2. X to the 4th divided by x to the 1st, you subtract those exponents to get x to the 3rd. Y cubed divided by y to the 1st is y to the 2nd. So that's what that first term reduces to. Next one, 12 divided by 3 would be positive 4. X cubed divided by x to the 1st would be x squared. Y squared divided by y to the 1st is y to the 1st. Minus, last one, 18 divided by 3 is 6. X squared divided by x to the 1st is x. And y to the 1st divided by itself is 1. They cancel. That's like y to the 0, which is 1. So there is the simplified answer right there. Okay, long division. So before we do this problem with these polynomials, I just want to remind you how to do long division with numbers, because people often forget. So if we wanted to do 52 going into 1049, here's how we would start. We would ask ourselves, and the 2 is there, but you're really looking at the 50. The 50 is the important part of that number. And you're asking yourself, how many times does 50 go into 1? It doesn't. How many times does it go into 10? It doesn't. How many times does it go into 104? So you look for the, again, you're looking more at the 100 part of that number rather than the 4 part. The 4 is kind of just along for the ride. So 52 goes into 104 2 times. That's another way of saying what's 104 divided by 52. It turns out to be 2. Then what do? We do 52 times 2, which is 104. We subtract those to get 0, and then we bring down the next thing, which is 9. Okay, 52 doesn't go into 9, or it goes in 0 times. Then we do 52 times 0, which is 0. We subtract those. There's nothing else to bring down there, so your final answer would be 20, and then this remainder 9 over 52. 20 and 9 over 52 remainder. So keeping that process in mind, let's do the exact same thing now with this polynomial. We'll take x minus 5, and we will ask ourselves, how many times does that go into x squared plus 3x minus 40? By the way, if any of the powers are missing, like if that was just x squared minus 40, you would have to write that as x squared plus 0x minus 40. Why do you need the 0? For the same reason you need the 0 over here with the numbers. If you try to do 52 and then say, well, there's a 0 in the hundreds place, so I don't need to write it, I'll just write 149. That problem that I just wrote, that's a totally different problem than 1049. This one says divided by 149. You need the 0 there, even though it's not an actual number. Same thing right here. Even though this problem has all the powers in here, if one of these are missing, you'd have to plug in a 0x or a 0x squared or whatever it is that's missing. Okay, let's remind ourselves how we did it with the numbers. We said, how many times does 50 go into this 100? And again, the 2 was just kind of there. We didn't really care so much about the 2. We cared more about the 50. It's the same thing right here. How many times does x go into x squared? The minus 5 is just along for the ride, so to speak. So another way of saying that is, what is x squared divided by x? And that equals x, or x to the 1st. Okay, then what do we do over with the numbers? Once we had this 2 right here, we did 2 times 52. So same thing right here. We'll do x times x minus 5. X times x is x squared. X times minus 5 is minus 5x. Let's go back to the numbers. What do we do once we did 2 times 52? We subtracted them. So we'll do the same thing right here. We'll subtract this and we'll subtract this. It's important that you subtract them both. Don't start adding. X squared minus x squared, well, those cancel. You just get 0. 3 minus negative 5, that's like 3 plus 5, so that's like plus 8x. And we don't really need the 0 there, so I'll get rid of it. Okay, so if you do this correctly, these first terms, the x squared, should be canceling out. Then what do we do with the numbers? Well, once we subtracted, we brought down this next number. So we're going to bring down this next thing right here. And then we do the same thing. How many times does x go into 8x? Or another way of saying that is, what is 8x divided by x? And that's positive 8. Then we do 8 times x, which is 8x. 8 times negative 5 is negative 40. We subtract 8x minus 8x is 0. Negative 40 minus negative 40, that's like plus 40, that's also 0. So you can write that as x plus 8 is your answer. You don't need to write the remainder. If there was a remainder, you would write it as remainder over what you divided by. So remainder over x minus 5. In this case, there's no remainder, so our answer is x plus 8. Okay, this type of problem right here, when they give you this to the negative 1, you might remember from the earlier section, raising something to the negative 1 is like flipping it and making it positive. So that's the same as 1 over 3 minus a. Okay. So what this means is we're doing this problem right here, x squared plus 7a minus 11 divided by 3 minus a. That's the problem that we need to do. So we'll do that using long division again. So I'll just put the a in front because that's the more important part of the problem. And then we have a squared plus 7a minus 11. We're not missing any powers. If we had been missing the a term, we need to put like a 0a right there. How many times does negative a go into a squared? That's another way of saying what is that division problem. And it turns out to be negative a to the first. Negative a times negative a is a squared. Negative a times 3 is negative 3a. Now we subtract them, so a squared minus a squared is canceling. 7a minus negative 3 is like 7a plus 3, which is 10a. Now we bring down the next thing. How many times does negative a go into 10a? That would be negative 10 times. Negative 10 times negative 10a is positive 10a. And negative 10 times 3 is negative 30. So now we'll subtract this. Those cancel. Negative 11 minus negative 30 is like plus 30. So negative 11 plus 30 is 19. So our answer is negative a minus 10 plus remainder 19 over negative a plus 3. So we need to look for that. It's multiple choice. Negative a minus 10, neither of those have that. Okay, this one right here, the only difference between C and D is this sign right here. If we look at what we have, this bottom right here is really 3 minus a, but there's a plus right there, so it has to be option C instead of option D. Okay, I'm going to show you now, that was long division. I'm going to show you what's called synthetic division, and we'll do a long division problem over here at the same time just to show you the similarities. So with synthetic division, what you do is you'd see what number makes this 0, and the answer is 4 would make that 0, so I'm going to put a 4 right there. Then I make kind of this box right here, and these numbers right here are going to be the coefficients that you see right here. So 2x cubed, I'm going to put the 2 right there, and I'll just put where that's coming from up above it. Then I'm going to put a negative 13 right there, because that's the coefficient on x squared. I'll put a 26, because that's where coefficient on x, and then finally a negative 24, which is the last term. Okay, so let's do this using long division. X goes into 2x cubed that many times, and then we multiply it. 2x squared minus 4 is that. And then we subtract. That becomes 0. Negative 13 minus negative 8 is like plus 8, so we get this. Bring this down. X goes into negative 5x squared, negative 5x times, and then we'll multiply it again. Negative 5x times negative 4 is 20x. Let's subtract that. Those cancel. That's 6x. And then we'll bring down the minus 24. X goes into that 6 times. And finally, when we subtract this last one, we get a remainder 0. So that's our answer. Let's compare that with synthetic division. The way that you synthetically divide is you add the columns, and then you multiply what's on the bottom. So here's how that looks. I add the columns. Well, right here there's a 0, so 2 plus 0 is 2. And then I multiply this bottom by the original. 4 times 2 is 8. Again, I'm going to add the columns, so negative 13 plus 8 is negative 5. I multiply the bottoms. Negative 5 times 4 is negative 20. Add the columns. 26 plus negative 20 is 6. Multiply the bottom. 6 times 4 is 24. And add those columns. And notice what we get. We get this right here. And if you look at the left side, how does that compare? Well, this started out as x cubed. But this is like we're dividing by a power of x. We're dividing x cubed by x to the first, so that's become 2x squared. This one right here, let me change the color. This one we divided by x squared by x to the first. So we're going to get x to the first. And then finally, this is x divided by x, so we get positive 6. You can see we get the exact same answer as the other side. Why would you want to use synthetic division? You can use synthetic division. It's a little bit faster when you have something that looks like this, when you have x to the first power, and when it's just a 1x to the first power, it's faster in those cases to use synthetic division than it is long division. Let's do another example here. Use synthetic division. Oh, actually, sorry, we just did this example, so we'll skip ahead. And this is kind of what I was just saying. You need to be dividing by something that's 1x to the first minus a number. So let's say minus 3. You can't do this if this is x to the second or x to the third. Synthetic division doesn't work for that. You'd have to use long division. Okay, and the other thing is, if it's not 1 in front, you can still use synthetic division, but you have to make a slight change, and I'll show you that as our last example. So notice this is x to the first, so we can do synthetic division, but we can't do it right now because it's 3, and we want that to be 1x to the first. That's the rule for synthetic division. So what you can do to change that is, well, how would you make 3 into 1? You would divide it by 3. So when you do that, you get 1x plus 1/3. And then because I divided the bottom of this by 3, I need to do the same on the top. So if I divide this thing by 3, 3x to the fourth divided by 3 is that. 5x to the third divided by 3 is this. X squared over 3 would be 1/3 x squared. And 7x over 3 is 7 over 3x. So now, when it's in this form, I can do synthetic division because it's, again, I'm dividing by something that's 1x to the first power. How do we synthetically divide? We ask ourselves what x value would make that 0. And the answer is negative 1/3. And now I fill this part with the coefficients. So this right here is a 1x to the fourth. Then we have a negative 5/3 x to the third. We have a 1/3 x squared. We have a 7/3 x. And then here's the thing I was mentioning before. Notice that we need to have all the powers filled in. So this is x to the fourth, x to the third, x to the second, x to the first. We're missing one. We're missing x to the 0, or just the number. So since there is no constant, I'm going to put a 0 right there. Because you can write this original one as that whole thing plus 0. You need to have every power filled in, starting at the highest one, x to the fourth, all the way down to the constant. If any of them is missing, you have to fill it in with a 0. Okay, now what do we do to synthetically divide? We just add these columns. There's a 0 there, and then we multiply these numbers. So 1 times negative 1/3 is this. I'll add the columns. Negative 5/3 plus negative 1/3 is negative 6/3. But negative 6/3 is the same as negative 2. So let's just write that as negative 2. Negative 2 times negative 1/3 is positive 2/3. And 1/3 plus 2/3, that's 3/3. But 3/3 is just 1. 1 times negative 1/3 is negative 1/3. Again, we add these. 7/3 plus negative 1/3 is 6/3. But once again, 6/3 is equivalent to 2. And then finally, 2 times negative 1/3 is negative 1/3. And we add these, we get negative 1/3. So what's our final answer? Well, this started as x to the fourth, but this represents dividing by a power of x. Remember, it represented dividing by x to the first plus 1/3. So if we divide x to the fourth by x to the first, we get x to the third. That means x to the third got divided and it shrunk its power by 1. All of these powers down here are going to go down by 1 from what they were up here. So that's x squared. This was x squared, so now it becomes x to the first. This was x to the first, and now it just becomes a number. And then this was a number, so this turns out to be the remainder right here. So our final answer would look like this. Our final answer would be x cubed minus 2x squared plus x plus 2 minus 1/3 over x plus 1/3. That's what we divided by. If you remember, we were dividing by, let me move up for a sec. We're dividing by this, so how can we clean that up just a little bit? Well, it's nice to not have fractions here and here. So if we multiply this by 3 and that by 3, you're able to do that because 3 divided by 3 equals 1. And anything times 1 is itself. So 1/3 times 3, that would be 1. And 3 distributed down here would be 3x plus 1. So this whole thing, let me just clean it up, it's going to be, this whole thing right here is the same as minus 1 over 3x plus 1. That's the remainder part, and the rest of this goes together with it. So that is just a brief intro to polynomial long division and synthetic division, section 5.2.